Hello and welcome. Today, in workshop technology subject of second semester common 12 branches, we will be talking about patterns and its types. Today is the 11th lecture. In the previous 10th lecture, we have covered almost all the second units. Now we are going into third unit, and after that, we'll be going to fourth unit. So we have earlier discussed about the casting process, and then we have casting process, and this was revision. This is just revision. And you can see here the casting process again given on your screen. So casting process is first we create a mold, and then we melt the metal into liquid form, and then we pour the metal into mold and then let it solidify. And once it is solidified, we open or break the mold, and we this way we take out the casting. So advantages of casting we have already discussed. Disadvantages, all these uh, steps in castings. Patterns, in last turn we were discussing about the patterns. We discussed about the type of function of a pattern. We were discussing about the material of the patterns. So in the pattern material, we talked about common materials that are used. 5 common materials I told. Then one is wood. Wood is the most popular and most commonly used material for patterns. So shisham is there, cal is there. Shisham is the hardest, and it has high strength. It is very costly material. So it is strong and durable. Cal is also very good. So these are problem is these are very commonly used materials, commonly used woods. Deodar is not as good as shisham. Again, teak wood is hard, very costly, and available to golden yellow or dark brown colors. Mahogany is also used. So these are five woods that are used for making pattern materials. So what are the benefits of wooden pattern? So first is wood can be easily worked. It is light in weight, easily available, cheap, but they do have many disadvantages. So they are very much exposure of moisture. So when moisture covers, when they are caught by moisture, and this way they are distorted. Wraps are there, knots are there. It's wears out quickly, sand abrasion, yes, and this weaker than metallic pattern. Obviously, they don't have as much strength as the metals are there. But the eight advantages are there, because of which they can be easily they are most widely used for making pattern. They are easy to join. They have good surface finish. They are laminated. They are repaired. They can be repaired easily. So these are the advantages that basically normally we go for the wooden patterns. So disadvantages are there, but disadvantages are less as compared to advantages. That's why wood is the most preferred material for patterns. The second is metal. Metal we already discussed this. What metals are there and why? What are the advantages? Cast iron, then brasses and bronze. These are metals. Aluminium alloys we have already discussed. Now we'll be talking also white metals. Then we'll be discussing about the advantages and disadvantages of metals. So advantages are they can be easily crafted. They can be easily crafted. They are easy. They are cheap. They are easy to work. They are strong. They have good surface finish. They have good resistance. So these are the advantages of the metals that we normally use in making patterns. And disadvantages are heavy, brittle, rust, etc. These are the disadvantages. That's why they are less preferred as compared to wood. Third are plastics. Plastics, as we know, are very much preferable. They have very good strength, but they cannot sustain higher temperatures. Plasters are there. We told about plaster of Paris and gypsum POP. They have advantages and disadvantages that we have already discussed. Then we have wax. Wax are also very good pattern material that's used for loss foam wax and wax we will discuss when we will discuss about special casting methods, that is Gauss form method. There we will discuss. As we told that wax cannot withstand high temperature, so at the same time they don't have as much strength as the other materials are. So wax is least preferred method, least preferred material for pattern making. So these are the factors that we have already discussed in last to last lecture. So today we will be talking about the types of patterns. So I just rebrushed the knowledge of casting and showing from the beginning the slides, so that once again the basic things are revised. So these are we are not going to discuss. We will be coming to the page 20, 21, that is types of patterns. These will be not discussing here. We have already discussed in the chamber section. We will be coming from here. This is types to pattern. Yesterday we discussed about in the last section lecture we discussed about the material of pattern. Today we'll be discussing types of pattern. What are the types of patterns? Pattern, as I told, that pattern is a replica or duplicate of the casting that is to take place. The part that is to be produced by casting, and pattern is the duplicate or replica. So we have 11 types of basic patterns. One is called first is called one piece or solid pattern. Then two-piece or split pattern, cope and drag, three-piece or multi-piece pattern, loose piece pattern, match plate, follow board pattern, gated pattern, sweep pattern, skeleton pattern, and segmental or part pattern. All we will be discussing today one by one. So first is single piece or solid piece pattern. This piece, when the pattern is made with a single piece and no complications are involved in the part, a very plain or very simple shape is to be given by casting. So there we use single piece pattern or solid piece pattern. This is easy to withdrawal and very normal shape and very convenient shape is given to this solid piece pattern or single piece pattern. But this is not case with all the parts. Mostly parts are complicated and parts have different geometries, difficult geometries, and difficult physical appearances. So these parts cannot be made by this single piece or simple or solid piece pattern. This solid pattern is only can be used for the castings who have very normal and very easy shape and very smooth shape of the castings. So for that we will be using two-piece pattern or three-piece pattern, multi-piece pattern, etc. So first we talked about single piece pattern. That is a very convenient shape and very simple shape. So in that case, we use single piece pattern. Now come to the two piece or split pattern. Split pattern, as the name tells, that a pattern is made in two pieces or split, and there is dowel pin or locating pins are there. These locating pins basically used to bind to the two parts of the pattern. So you can see these dowel pins are given here. So symmetrical parts are there, both up and down, lower and upper part are symmetrical, and they don't have any difference and very much symmetrical to it. But they cannot be made by single piece pattern because the geometry is typical. Geometry is tough. Physical shape is tough. So it cannot be. It cannot be. Built, it cannot be it cannot be made by single piece pattern. So we basically use two piece or split piece pattern where we have different shapes, two or three different, where we have two pieces, and complex geometries are achieved by two piece or solid piece pattern. Now there are, you can see dowel holes are there. These dowels are pins, locating pins that are guide into the dowel holes, and this way the two pieces are retained together. Hoop and drag pattern, at the time of introduction to casting, I told about the hoop and drag sections. These are two sections of molds, and similarly these are two patterns are there. In that case we were discussing about the cylindrical molding shell in which the mold is made. Similarly, patterns also are split into two pieces, and such that when they are vertical, the upper part is known as scope and lower part is known as drag. So we can see when the pattern is heavy and pattern is made up of vertical pieces, so in that case the upper part is known as scope and lower part is known as drag. So scope and drag pattern is a heavier pattern made up of two halves, two pieces, which are mounted on different plates. So above part is known as scope and lower part, this is scope pattern. You can see easily that upper part is there. This is different, slightly different from the lower part. Symmetrical, somehow symmetrical, somewhat symmetrical, but there are differences between upper part and lower part. You can see this opening is given here, whereas no opening is given this side. So this is upper part is scope and lower part is known as drag. And when we have more complicated shapes of more complicated geometries, then we do have three-piece or multi-piece pattern. When the pattern cannot be made in two pieces, the three pieces, three different types of pieces are the whole pattern is made in three different pieces, and these three different pieces are clubbed together to make a single pattern. So these are three pieces pattern and multi-piece pattern or multi-piece pattern. So we can say these, therefore these patterns are made in either three pieces or multi pieces. Multi-molding flasks are needed to make mold from these patterns. Now we have loose piece patterns. Loose piece patterns, the patterns in which some part is loose and can be, some part can be fixed and taken out at the time whenever required. At our ease, at our convenience, we can remove the part or we can apply the part. This is known as loose piece pattern. So this you can see, making a single piece pattern would have been hard, would have been tough, and also at the same time removing the pattern from the mold is also typical job. So what we have done, we have made pieces A and B separately, and this plane geometry is made by single piece, and these two complex geometries are mounted. Piece A and B complex geometries are mounted, and these intricate molds, intricate shapes are known as loose piece, and the whole pattern is known as loose piece pattern. So loose pieces are the extra projections, extra hangings, overhangings that basically obstruct in making a single piece pattern. So these are extra overhangings, over projections are mounted by application of certain nail or screws. So these are known as loose piece pattern. Now coming match plate pattern, we have a match plate. Match plate is when we have multiple patterns, we have to take casting, we have the part is small and it is made in two halves, and the pattern is made in two halves and is mounted on opposite sides of a wooden or metallic plate is known as match plate. That means these are patterns, number of patterns are there, and we have match plate in between them. So number of patterns are made in single piece, and similarly there are lower piece, there are different symmetrical pieces uh, to the upper portion, and when these two are mounted together on wooden or metallic plates, they are known, this pattern is known as match plate pattern. So you can see runner is there, patterns are there, match plate, hole for locating. So these are for alignment. So these two different patterns, upper pattern and lower pattern, are mounted on match plate, and match plate are together matched by locating pins or locating holes. So there is runner, and runner basically provides the molten metal to all the patterns, and this way casting is done. So these are known as match plate patterns. And then follow board pattern. Sometimes the pattern is sometimes pattern follow board pattern. Sometimes pattern, you can see, is not in the strength, it doesn't have, its shape is complicated and it cannot withhold the load of the sand. So you can see here we have a pattern, and this pattern, when sand is filled over this, when this sand is filled over this, it would be probably distorted, and it may collapse. So we have a follow board, a support board, that basically gives support to the pattern, and this way this pattern gets strength by the board, by an additional board that is called follow board. So follow board pattern is a pattern that has complicated and fragile shape of the pattern, so that this fragile shape can distort and this fragile shape collapse when the molding sand is filled in the molding flask. So in order to provide strength, follow board, another board, extra board is provided to this pattern, is called this follow board pattern. Now gated patterns are there. Gated patterns, when there are gates on the patterns, many gates are given, you can see there are a number of patterns are there, and gates are given there. These are gates, in gates, molten metal. This is runner, molten metal coming from either from left side. Molten metal enters either from left or right side, and if it is coming from left side, it is coming and enters into this pattern, this pattern. Similarly, going metal here, moving to this pattern, then going here, this pattern, going here, this pattern, this pattern. So these are the gates, as I earlier told in the first lecture, that ingates are the beginnings, ingates are the entrance to the mold. So when these patterns are given, they are also at the same time, gates are also made along with runner. So these are known as gated patterns that have basically entrance provided to the pattern. These patterns are made of metal and plastic pieces to form gates, and runners are attached to this pattern. These are known as gated pattern. Second one is, ninth one is sweep pattern. Sweep pattern is, we have a symmetrical shape or circular shape. So what we do, rather making a complete circle, what we do, we make a segment, circular, complete making complete circular pattern. What we do, we make a shape, quarter or 1/8 shape, and then we sweep all over to make a complete circle, a complete symmetrical pattern. So we can see there we have sweep pattern like this. So this pattern is swept in the circular fashion, circular motion. So we can see that first 1/8, then again 1/8, again 1/8, again 1/8, again 1/8. So in 8 steps, the whole cavity can be created. This is basically used for large patterns where the cost of pattern is making high. So rather than making a complete pattern, we make segment of it, and then we sweep and we rotate the pattern and create the actual cavity and create and make a mold. So we have a pivot end that is attached to a stake of metal in the center of the mold. This pivot is responsible for sweeping or for rotation of the pattern. This is known as sweep pattern. Then we have, after sweep pattern, we have skeleton pattern. Two more patterns are there, skeleton and segmental pattern. Skeleton pattern is, number of large and heavy castings are to be made. It is not economical to make a solid pattern, because number of large and heavy castings, large when the casting is large and heavy, so the pattern is also large. So when the large pattern is there, so making it rather than making it solid pattern, what we make a skeleton pattern. That means we make ribs of the pattern, and this way we achieve our objective of creating mold. So skeleton patterns are the patterns that are made up of ribs and made up of reinforcements, and they don't have solid pieces and they don't have solid material. So skeleton patterns are used for large and heavy casting. At the same time, they are made up of ribbed construction of wood, which forms an outline of the pattern, or reinforced material, or ribs, or we can say structural materials. So skeleton patterns are made up of ribs, etc. So that rather than whole solidified, we make a cage of it, and this cage or framework is filled with loam sand and dry. The surplus sand is removed by a stickle board for round shape. The pattern is made in two halves, which are joined by glue or by means of screws, etc. A typical skeleton pattern is shown in figure 1.20. Skeleton pattern is shown in this figure. Last one is segmental pattern. Segmental pattern, we discussed about the sweep pattern. This is more or less to sweep pattern. Sweep pattern, in segmental pattern, we make in sweep pattern we make 1 by 8 or 1 by 16th or 1 by 4th of the whole pattern, and we swept. Similarly, we make a segmental pattern, and there are different segments. The whole, when the casting is large and circular, for example, wheel, rim, gear blank, etc. So such patterns are section of a pattern, so arranged as to form a complete mold by being moved to form each section of the mold. So there is a central pivot about which, central axis about which the segmental pattern is rotated, and this way segmental pattern is rotated and completes making a mold. So segmental pattern and sweep pattern are almost similar, but the difference is the segmental pattern has many segments, whereas sweep pattern has one pattern, one segment of the pattern, one by eighth or quarter or 1/16th of the whole pattern, and that is rotated and swept around an axis. This way, it forms the whole. It forms the whole mold whole pattern. Okay, so these were 11 types of patterns, and everything is given. Everything is explained along with all neat figures, so you can see, and these are much more than required. Today, another topic we'll be discussing is pattern allowances. What are the pattern allowances? Pattern allowances are the additional material that is given to the pattern. Additional material, additional what is this additional material? If we have to make a pattern of 10 millimeter dimension or 10 centimeter dimension, we make the pattern slightly larger than the 10 millimeter. And what is this slightly larger dimension? That is large, this dimension that is given to the pattern, added to the pattern, and that is not the case with the original casting. So if a part is to be made of 10 millimeter, we keep the pattern slightly larger, maybe 11, maybe 12 mm. So this 2 mm is increased because of various reasons. So we'll be discussing these reasons and why these reasons are taken, and how these reasons are taken, and what are they. So in place of 10, we are making the pattern as 12 mm. So this 2 mm is known as allowances. Extra material is given on the pattern. So why these extra material is given? Why it is not, when we have to make a die of 10, why we are not taking 10, why we are taking 12? Because of these factors that are shown on the screen. First is shrinkage or contraction allowance. If we want to make a shaft of 10 mm and we make the pattern of 10 mm, we don't give any allowance. We don't give any additional material. So what will happen at the time of solidification? At the time of solidification or cooling, the metal gets shrink. So we have made pattern of 10 mm, and the shaft will be shrinked and will be of 9 mm or 9.5 mm. This will be under the requirement. The requirement was 10 mm shaft, 10 mm die of shaft, but the material that is casted has now decreased to 9.5 or 9 mm. So this shrinkage is responsible, this shrinkage is compensated in the pattern itself. So we make, rather than making 10 mm pattern, we make 11 mm pattern, so that after shrinkage, after solidification, the metal is now 10 mm. So this is very much convenient. So first is shrinkage allowance, another is machining or finish allowance. Because we know when the casting is done, this upper part, the surface is very much poor. Because of it comes in contact with the sand, and this sand distorts the surface finish. This sand is does not provide good surface finish to the metal. So removing this rough surface removing this rough surface and giving good finish to the material, the part is machined. So top layer is removed, and for this removal of top material, extra material is given so that when finish is done, the dimension does not fall below the standards. So this way machining allowance is added. Then draft or taper allowance. This is draft or taper allowance. Rather than vertical walls, rather than vertical, these are kept slightly inclined so that the withdrawal of the pattern from the mold is easy. So this is known as draft or taper allowance. Wrapping or shake allowance, the pattern is kept in the molding flask and the sand is rammed all over it. So the pattern may get stuck. So what we do, we wrap the mold by hammering or by patting. So this way, uh, in order to lose the pattern from the molding sand. So this is called wrapping or shake allowance. So we shake or wrap the mold from the outside, and this way the stick mold with the pattern gets loosened and allows space to pattern so that it is taken out. Distortion and camber allowance, material often gets distorted while casting. So this allowance is given so that distortion is removed. Mold wall movement allowance. This movement this allowance is given because many times the wall of the mold is moved and there is chances that we may not get the accurate part that we have that we are working for. So there are mold wall movement. So these are detailed one by one. Then liquid shrinkage or contraction allowance, liquid shrinkage. First, the liquid gets converted to solid, then gets solidifies, and solid material at elevated temperature comes to the normal temperature. So shrinkage or contraction allowance is there. This is the basic idea of what allowance is given. Gray cast iron, 0.125 inch per feet. This is the allowance that is given. Gray cast iron, cast steel, aluminum. So 0.125 inch per feet. Up to 2 feet, up to 4 feet, this is 0.083. And this gray cast iron, aluminum, these are the allowances, shrinkage allowance for various metals. Now, shrinkage allowance, then machining allowance. Machining allowance is given 3 to 18 mm. Highest is 18 mm, highest too much, but very big parts we are given 80 mm, but normally we are given to 3 to 5 mm machining allowance so that we remove the surface, the rough surface from the part produced. So this is machining allowance 3 to 18 mm. Draft or taper allowance is 20 mm per meter, 10 to 20 mm per meter. So this is so simple, 10 to 20 mm per meter, because withdrawal of the straight taper would have been difficult and may distort the sides of a mold. So this way, drop the taper allowance given. Wrapping or shake allowance, this is normally 1 mm, slightly dimension, normally 1 mm. Then distortion allowance is there. Uh, distortion allowance is not given. Distortion allowance is also there. Then mold wall movement allowance. Mold wall movement in sand mold occur as a result of heat and static pressure on the surface layer of the sand on the mold metal surface. In ferrous castings, it is due to expansion due to graphitization. This enlargement is the mold cavity depends upon the mold density and mold composition. This effect becomes more pronounced with increase in moisture content temperature. So when the molten metal is poured into the cavity, into the mold, there are chances that sides of the molds and walls of the mold may get distorted because of heavy heat, because the molten temperature is 16 degrees centigrade, melting temperature of mostly metals, heavy metals. So at 1600 degree centigrade, the walls of the mold may get distorted and may collapse. So this way, an additional allowance and additional material is given to the pattern so that their walls are safe. So these were the allowances that are provided to the molten, provided to the patterns. Now life expectancy of the patterns, these are the basic number. A basic number is given. Loose piece pattern, softwood, hardwood, 10 to 50 number of molds, 1000 pattern material. So this is epoxy resin. These are the patterns and their expectancy, how many times they can be used. So this is a rough idea. This is not the part of the syllabus, only given for the sake of knowledge. So next we will be discussing molding sand. Today we discussed patterns, pattern materials, advantages and disadvantages, and also different types of allowances that are given. So why they are given? So this was all about pattern and pattern allowances. So in case is still not clear anything, any doubts, you may get in touch with me on my phone number. My phone is 9069 360 400. So for the time being, I am signing off. Bye.